So at this stage, you're probably going to ask, well, what's the use of this number? What does it telling me? Well, what happened is that if these two set of data is actually no difference from each other, so if they are no different from each other, for example, let's say I have two sets of data, x, y, right? There are no difference. 1, 1, 2, 2, 3, 3, 4, 4, for example, right? So in this case, d squared is going to be always the same, right? There's no difference. Therefore, using the RS, and here is perfectly correlated, and they are positively related. Positively related, that means x increases, y increases, or x decreases, y increases. So this is a perfect correlation, positive correlation. Here we have also perfect correlation, but in a different direction, right? X increases, y decreases, or x decreases, y increases. So this is an inverse relationship. It's a perfect inverse relationship. Go back to our frame number 2. Well, we get this page 0.7857. What do we do now? Well, is this number actually significant or not? Well, to answer this question, we really need to go to something else. We need to actually do a testing. For example, we go back to my page here, statistical package. Okay, and in statistical package, all right, click on something called the Spearman rank table over here. Spearman rank table. And in the Spearman rank table, we look at, this is a table that you can also obtain from other websites. We look at what is our sample size. Well, our sample size in this case is 7. If you have a 5% sensitivity analysis, the null hypothesis is that R of S is actually equal to 0. That's the two set of data actually are not related to each other. The alternative, because our number is actually larger than 0, 0.787 is a positive number, that the correlationship is actually positive. And we let it to be 5% significant level. At 5% significant level, the critical value is 0. From the website, we see that the answer is 7143.7143, right? And then now we make a decision. Our statistics, our RS is 0.7857, which is more than 0.7143. Therefore, thus we can reject the null hypothesis and fail to reject H1. The alternative, that is, what we're going to conclude is that we're going to conclude that the ranking X and Y are positively correlated. That is, these two rankings are positively correlated. Well, how about at 2.5%? 2.5% significant level. Well, in this case, the critical value is going to be different. The critical value in this case is going to be 0.7857. 0.7857, which is exactly the same as the one we have. So we can say, well, because this is not larger, so we will, to be on the conservative side, we will be failed to reject provisional. That is, we will believe that these two rankings are actually not correlated if we want to be conservative, because this value is right at the border of critical value.